The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone. I'd like to welcome you back to another KevCAM night class tonight. Tonight, I have Tim Carl helping out with any questions that come along the way for you guys. Tim, are you with us?
I'm here.
And of course, we can't forget the good old Greg Payton to make sure I'm not skipping anything for everyone.
Good evening, everybody.
Ronnie Kidder says, good evening, gentlemen. Welcome, Ronnie.
Long time no talk, Ronnie. All right, so I do see one new name in here. So just some quick housekeeping before we get started here. We are using GoToWebinar, and that just puts everyone in mute to eliminate any background noise. If you guys do have a question, definitely go ahead and type those into the questions panel, and then Tim will let me know when there's a question and read it off to me, and we'll get those answered right away for you. These night classes are solely dedicated for you guys, so definitely feel free to ask questions. A very laid back class, and with that being said, we will get, one other thing, every night class is recorded. So if you guys would like to see a previous night class, you guys can go over to the SolidCAM University, and you can see all the night classes here, along with some live cuts that we put in there, and some quick tips and tricks, and some medium-sized videos, and all kinds of good stuff in here. So, all right. So with that being said, we will get the ball rolling tonight with thread milling. So we'll cover the basics of, well, pretty much everything for you guys for thread milling here. We'll start off with some pipe taps, and then we will get over to some regular taps, and then we'll actually get into cutting some cosmetic threads as well. So with that being said, got my part here in a vise, got my setup here, everything's ready to go, so we can start off with thread milling. Now, Greg mentioned a couple weeks ago when we were in drilling that if you guys are in a drilling operation, let me just actually open that up right now. If you are in a drilling operation, and let's say we've already drilled these holes with the drilling op, you guys can make a copy of that drilling op and then come up here and actually switch it over to thread milling. So it eliminates having to exit out and start a thread milling operation where you can just do save and copy, which is save you just a little bit of time there. Okay, so just like drilling geometry, thread milling is looking for a single center point of that hole. So it doesn't matter what size we're doing, if we're grabbing this hub right here for thread milling, or we're grabbing the circle right here, all it's doing is finding the center point. So with that being said, is if you guys don't have a center point in there, what we can do is we can just grab a center point, or we can put that wherever. So it's basically a drilling operation for your geometry. So let's go ahead and grab some geometry here. And we'll start off with a 3/4 or 3/4 NPT. So for that one, all I have to do is just click anywhere on the diameter of it, or like I said, we can click on the center point and it's going to automatically grab it. And this is using the same geometry selection as drilling does. So like we talked about, we can do pick position, we can do 3 points on the circumference, multi-position, or all arcs and centers there. So we have our 3/4 NPT, and go to our tool. Now this is where it gets a little bit different. So for national pipe taps, or any kind of pipe tap, the British pipe tap, that is always going to be a tapered thread mill. So any straight threads, like our 3/16, any of our metric threads, that's always going to be just a straight thread mill. So we'll just go ahead and click on that tapered thread mill. And the first thing it's going to want you to do is choose what kind of thread that we're working with. So if we grab the drop down here, and we are going to be cutting a NPT. And we can just find one out of the list that we're cutting in here, or that we're going to be using. So we're using a 3/4 14 in here. Now, if it's not in here, we can actually create our own pitch and our angle and all that stuff in there as well. But since we are running a National Pipe Tap 3/4 14, we can just click on it, hit OK. And what it will do is it will populate the threads per inch, diameters, everything that we need to go along with that 3/4 NPT. Now right here is our tool angle. So maybe our thread mill might be a little bit smaller, might be a little bit bigger. You can kind of see right here, I got a thread mill that it automatically threw in there for me. You guys can change this around however you'd like. Now, one thing that is very important is the number of teeth. So let me open up this right here, and it's going to show our tool. Now, if we're running number of teeth, which I'm looking at this number right here. So from tooth to tooth to tooth, how many do we have there? So the larger I make this value here, the increased cutting length that we'll have in there. So if I did a 6 tooth, you'll see that it automatically grew my total cutting length. So this is all dependent on what kind of tool that you guys are using. Maybe for this one, we're using a 10 tooth, and we can do it all in one cut. So we got our taper angle, which is automatically kind of put in there, and it's on a auto calculate basis off of the threads per inch and the number of teeth. And then as well as our outside holder and our shoulder length that we've done before. Well, we can put a holder on there as well. We can put our coolant on there. But for right now, we'll go ahead and accept that. And we'll go to our levels. And my upper level, I can click on this face right here. And our thread depth. So you can do your thread depth based off of an actual value, or we can do it based off of number of threads. So whatever your print specifies, we can actually put that in there. Now, if we want to go a little bit farther past, so we're not cutting right on the tip or stopping right at the 0.5, we can do a additional depth of, let's just do 50 thou. All right, so we got our upper level set, we got our thread depth set, or base value, the levels right there. Now we can go to our technology. Now, starting at the top over here, if we are doing multiple holes, this is how it is going to organize all the holes. So by default is how the engineer designed the part, or we can go off of shortest distance. The advanced tab is going to be just like what we kind of covered in the drilling, is we can do different patterns based off of what we're trying to cut there. So we got linear, or we can go to circular patterns. But since we're cutting just one hole, it doesn't really matter here. Do we want to run cutter comp? So we can turn that on or off. Now, are we cutting an internal thread or external thread? Now, this number right here does get a little bit confusing. So if we're cutting internal thread, let me just bring up this dialog for this one right here. So if we're cutting an internal thread, we are looking for the major diameter. If we are cutting an external thread, we are also looking for the major thread diameter. But in the picture, if I turn it to external, you'll see that the picture really doesn't match what's going on here. So think of this as the major diameter for both the internal or external. Okay. All right. So right here, do we want right-hand threads, left-hand threads? Kind of self-explanatory. Do we want to, this is kind of more geared towards a smaller amount of teeth or a single tooth thread mill here, but do we want to start at the bottom and work our way up, or do we want to start at the top and work our way down? So I personally like to start at the top and I'll just kind of work my way down. But like I said, with this tool, if I get it on our screen here, you'll see that I have plenty of cutting length there, so I really don't have to worry about it. Now, with the roughing strategy, so if I go back to my tool and I hit select here, and if I click on the NPT, it's telling me for my 3/4 NPT, I need to have my drill, or that hole drilled out to 905 thou, and cylinder prep to 1.04. So if we have too much material there, obviously we can snap off our thread mill, but what we can do to compensate for that is we can do a roughing operation with a clear offset. So if we're looking for really, there's different classifications of threads, and I'm having a complete brain fart right now. Maybe Greg can help me out here, but is it class A, class B, class C, or class 1, 2, and 3? Or maybe Greg doesn't know either.
No, it depends on the standard that you're working with. Like if you're looking at the UN version, then yeah, A, B, and C. Metric has its own standards, and it's basically a fitment tolerance, though.
Yeah, for the those of you guys that have like the thread gauges, you know, you can do one turn above, one turn below kind of deal, but depends on how tight of tolerance you're looking for. So if we want to do a wall offset of, you know, 1 thou for a really tight fitting thread, or, you know, something a little bit larger to go for a little bit where we don't have to worry about the classification so much. As well as our clear offset here, I can offset our tool path just like in profile operation that we talked about by offsetting the entire geometry. So if I put in here 15 thou, what it will do is it will come down as I have it set right now, and if I did this at a 5 thou step over, it's going to offset the geometry by 15 thou plus our wall offset. So we're going to be offsetting everything by 20 thou, and it's going to start and go right up to size plus that 20 thou, and then take a pass. And then it's going to step over 5 thou, take a pass. Step over another 5 thou, take a pass, when it all the way up until it gets up to the final diameter size. So let me, my mouse is all over the place here.
And that's going to act as like a clear offset, like what you showed in the profile passes as well, for roughing something and then using a finish pass to get it to its nominal size.
So if we come in here, I'm going to zoom in just to this specific tool path here. Let me get a straight down view. Turn off our tool here. So here is our clear offset that let me get back to the screen here. Here's our clear offset of 15 thou. So it's taking a pass, moving over 5 thou, taking a pass, moving over 5 thou, taking a pass, and then that leaves us up with that last 5 thou, and that last 5 thou is taking the pass in there. Now, right now, we are starting, if we're looking straight down on this, we're starting at the 90-degree kind of quadrant, I guess you could say. The start angle right here, I can modify this to however I would like. So if I want to do 270 degrees, it'll bring it over to here. Now, where this really comes into factor is multiple thread starts. So if we did a 0, and then if we wanted to have multiple thread starts, if I do save and copy here, and I switch this over to 180, now we have two different thread start points. So if you guys are looking for multiple thread start points or multiple, I'm trying to think of the name of it, but I think it's just start points. If you're running multi-threads inside of one hole, and typically you wouldn't run that with pipe tap, but just standard thread. That way you can screw that bolt in instead of being clocked at that certain amount of degrees. You can start it at 0 or 180 degrees, depending on what you guys put in here. So does that kind of make sense for everybody with the start angle, what I'm getting at with the multiple start points? Ronnie, is that making sense?
Yeah, I believe so.
Okay.
Another good place that it can be used for is if you have two different parts that are threaded and you want to make sure that the threads are clocked in a specific way to where when both pieces made up, you have the correct orientation. You can use the start angle to make sure that you have that appropriate clocking when you thread those two pieces together.
Yeah, that's a great point. Great point. All right, and you guys can do multiple passes for your finish pass. Forgot to mention that. Now, if we get to the linking, there's not much in here, but basically, anytime we're doing a thread mill, we want to kind of start in the center and work our way out. But you do have the option to do a flat retract or retreat. And then our motion control and miscellaneous parameters are going to be the same as what you guys have been seeing all the way through with face mill, profile, pocket, drilling, all that stuff. Okay, so we got our 3/4 NPT in there. We'll go ahead and do just another quick 1/4 inch NPT. So go to our new geometry, grab our NP or a 1/4 inch, grab our tool here. And for some reason, the go-to-web area really messes with my mouse here. Tapered. And we'll go to our NPT, and we're cutting 1/4 18. Okay. And we'll just leave this we'll do this as a single flute, or a single cut. Yep.
Mr. Ronnie Kidder had a question. He says, I'm not paying close enough attention. I'm working. When do you use the NPTF in the tool table, since you use the NPT for an internal thread? If you are already answered, I'll watch the replay.
So NP there. So pipe tap is no different. Okay, so I'm just pulling up NPTF, and we are running 1/4 18. And so there is no difference between.
I think Ronnie's going for a stump the chump type question. So NPT is taper pipe for fluids, and then NPTF, if I remember correctly, is taper pipe for fuels. So if you get something that's a lot thinner, you get a little better connection, I believe. You'd have to Google that one to cross-check me on that.
And I know with the British National Pipe Tap is also the same. So I'll have to look into that one for you, Ronnie. I don't know the difference. It could just be classifications of threads, maybe, between NPT and NPTF Carmex, but these are all.
He said he thought NPTF was female.
That could be. I guess I didn't. Let me.
No, I think it's for fuel.
Fuel?
As opposed to common fluids. I believe so.
Okay. No,
I'll look it up.
We'll look into it, Ronnie, for you. All I know is with usually NPT, they're all the same because it's just a pipe tap. But the fluids one is new to me. Okay, so we got our quarter 18 for Ronnie. Completely sidetracked. No, I'm just kidding, Ronnie. For those of you that are new, I love picking on Ronnie, so I gotta have one guy to pick on. All right, so we're gonna do this as a single tooth thread mill. So we got number of teeth set as 1, and now for our levels, I'll tell it that I want to go down to basically the bottom of the part. Technology, like I said, it automatically puts our thread data in there, so I don't have to worry about that. We're cutting right-hand thread. I want to start at the top, work our way down. And let's say that we end milled this out, so it's already good on size. So we just need to do one finish pass. Well, then got a my thread is not. Let me go upper level, and I forgot to set my upper level. So now, as I did that save and calculate, we can see that it's doing an actual helix working its way all the way down to the bottom now, since we're using a single point thread mill. And if we go ahead and play this through in our Solid Verify here, we can see it's doing a nice helical entry, working its way down with a, let me get a top-down view for you guys. You can see that it's starting, you get a straight top-down. So we're starting on, since we're working with an NPT, it's doing a cone shape. So we're starting in and working our way out. Or I'm sorry, starting on the outside and working our way in, so it's tapered in for the NPT. So, okay, enough with pipe taps. Any questions with pipe taps other than the NPTF? I'm sure Greg will fill us in once we figure that out here. So what we can do now is just do standard threading, and this is it's just telling me it's a threaded hole. What is this? So a quarter 13 tap or a threaded hole. So what we can do is go to our thread milling and go right to our, boy, my mouse is just driving me nuts here. New. Accept that. Got our thread. And we will go ahead and add a straight thread mill. And it's asking me to choose a standard. So we're going to use UN. And we are using a half 13. So I can go find our half 13. It has our drill prep diameter and our cylinder prep diameter in there. Go ahead and hit OK. I'll just kind of leave this stuff alone in there, because depending on the thread mill that you guys have, you would have to input that data in there. Levels, upper level is here, and our lower level of our part right there. And technology, we are cutting an internal thread, which the major thread diameter is going to be a ½ inch because we're cutting a half 13. Starting at the top, working our way down to the bottom. And we'll go ahead and do a wall offset of 5. And I did forget to tell you guys, we did a 15 thou clear offset. So right now, as it's set is, it's going to do a constant step over of whatever value I put in there. Now, what you guys can also do is, instead of doing a constant, we can do different variables. So the first pass is going to take 50% of it. Second pass is going to take 75% of it, and third pass will take 100% of it. Or we can set up to variable 2, so it just does it in 2 passes, or variable 1, which takes all in 1 pass there. So you do have a couple options right there. I personally like to do the step over, but completely up to you guys. And I think we have everything set here. We'll go ahead and save and calculate. And we can go ahead and simulate this. And we can see it doing the helical entry in there. And you can see that we're doing the multiple passes as well. So we should have a total of 4 passes going on there, which we did. And the 4 passes, kind of like we talked about. So we're doing 15 thou with 5 thou step over. So we got, 5, 10, 15. So we got passes there, plus the rough pass, which will get us all our passes in there. Okay. So same thing is going to kind of go, this is for a 3A16. Same thing for, I think you guys are getting kind of bored with the internal threads. So same thing would apply for the 3A16 as well. And for the, I think this is a 1/4-20. So now let's go ahead and do a boss as if we're doing threading up a boss that would be sticking up. Back to my SolidCAM tab here. And we'll go ahead and add our thread milling. And I'll just click on that circle there. And I found the center point for us. And this one is 1/8 inch NPT. So we will do a tapered. And we will go with our 1/8 inch, 27. And we can do this as a single point for this one here. Levels, upper level is the top of our thread part. Bottom is the bottom of our face. And technology. So now we are doing external threads. Now we may have to adjust the major diameter for those threads. So right now it is saying we are 333. Now usually you'd have a print to go off of, but I'm just going to look at my cylinder prep size. So we have 1/8, and we need to be at 334. I think. Let's see if I can click on this and get the exact value for you as well. Oh, it's pretty close. 333. So we'll just do 334. Okay. And we are doing external. We want to do right-hand threads. And do you guys want to start at the top and work your way down, or the bottom up? And now we can do save and calculate and go ahead and simulate this. And just with like a typical thread mill here, we're going through. And actually, I told it the wrong diameter because we just machined up a whole lot of material there, which is great for why we have Solid Verify. Let me go to select here. I'm gonna grab. So we need to be 383. Sorry. So I'll put in here my 383. Save and calculate. Now we're cutting threads in there. Now you'll see that we actually have cosmetic threads over here, but it's wiping them out. And that's just because of the thread mill. So if we look at our thread mill here, if I get it out there, you'll see that it's just represented with a complete circle, and there's no teeth in there. Now, if you guys would like to see those cosmetic threads when you do the Solid Verify. I'll show you that on our last one with our half 13. But if you guys are doing just standard thread milling and you really don't care about the cosmetic threads in the Solid Verify, it has no effect to the G code at all. But if you want to see them there, then what you guys will have to do is do a shape tool. Otherwise, it will just be a straight cylinder and it will just show it kind of wiping out the threads there up to the minor diameter. Okay. So we'll go ahead and do our 3/16 here. Do new. All right, got our center point. Tool select. Go ahead and add a straight using a US 3/16. And I should have looked. Cylinder needs to be at 375, obviously. Okay. We're good to go there. Levels. My upper level can be the top here. And my lower level is going to be right down to that face. And we are doing external at 3/16, so we can put our 3/8 in there. And starting at the top, working our way down. Save and calculate. We can go ahead and simulate this. So you can see we're going straight down, grabbing those threads, but like I said, it's not showing much action going on there because we're using just a cylinder. Now, like what Greg was saying earlier, if we want to change that clock position or our start angle, we can definitely do that. And we can set it to whatever angle that you guys would like to have in there. So you can see that it shifted it over for you. Now, the moment that Ronnie's been waiting for all night is cutting cosmetic threads. So, and what I mean by cosmetic threads is right here, I just have a boss sticking out, where over here, I have an actual bolt sticking out so I can see the threads itself. But when I go to play this through, and well, let's just do it real quick. If I do our thread milling and geometry, oh, come on. Go ahead and add a half 13. And levels right there. Depth is right there. Technology, external, half-inch major diameter. Save and calculate. And let's go ahead and play this through. Oh, we're starting at the bottom, working our way up. But as you can see right now, all it really looks like is a end mill doing a helical working its way around. So if we want to actually see those threads in there, what we need to do is create a shape tool. So for that to be done, we can go to our tools, SolidCAM, and tool library and do a shape tool. And we'll go ahead and add a shape in there, and I can come in here and just say -2, 13, single point. All right. So for those of you guys that are new at making shape tools, you can definitely check out on how to make shape tools in there. So I'll kind of buzz through this a little bit quick here, but I'm starting off with our lower. There's our that and one more. Okay, so my cone 1. Now, unfortunately, I don't have these numbers memorized, so what I'm going to do is, let's see, we want our D1 is right here for half 13 is 388. So I can come over here and do top diameter is 0.388. And our bottom diameter is going to be, actually what I'll do is I'll do auto calculate. I forgot about that. So bottom diameter, I'm going to do auto calculate with an angle of minus 60 degrees. Sorry, that's going to be a positive 60. And our height will be, and I'm sorry guys, I'm just pulling this right off of Harvey's website here. D1, shank fluids, overall length, neck.
I almost feel like we need Tim to do the shameless Harvey Tool plug.
Yeah, 294. So our $294. Okay, there we go. Okay, so we got cone 1. Cone 2, top diameter is, I forgot, 294. 294. This was 388.388. Do auto calculate for the height.
Now, while Kevin's going through that, if you guys are looking for importable tool libraries, Harvey Tool does have a SolidCAM friendly file that you can import into the system if you do use their tools. So be sure to check out their website and get that download. It's a pretty cool resource for you guys.
All right, so we got our tip done. Now we need our cylinder, which is this area right here. So the L3 is the number we're looking for, and L2, L3. And for our half 13, I'll do 3/4. .75, and this will be 294. 294. So this does take a little bit of time to build out your shape tool here. But if you guys are looking for those cosmetic threads, this is the way to do it. And our shank diameter is D2. And let's go to D2, ½ inch. So say 0.5. And that looks good. Okay, so now we have our half 13 single point thread mill here. 60-degree angles. All our data is put in there correctly. Now what I can do is save and close. And what we'll do here is open up that half 13 thread mill that we were doing, and we will go ahead and add a new tool. So we can do
Kevin,
yep.
for the sake of being a stickler,
Mm-hmm.
the thread angle is going to be 60 degrees total. You have it as 60 degrees on either angle.
Oh, do I? Okay. So what we can do is grab our half 13. And the nice thing with the shape tools is we can actually change that. So we'll go to our shape tab and we'll grab our half 13. And if I go ahead and show our tool over here, you can see it right there. And Greg, come on, auto calculate for the height. We'll do 30 and minus 30. Some reason that doesn't look right though. That doesn't look sharp enough for us. Does that still not look sharp enough, Greg? To me, that looks. Well, I can look into that a little bit later. But basically what I'm mimicking is this tool right here going off of the specs off of the Harvey tool side here. So we got our threads, or our shape tool in there. So now we can go ahead and accept that. And our level is still going to be the same, still doing a half 13. But now, if we go ahead and simulate this through, and we're starting at the bottom and working our way up on this one, but we can change it around. So now you guys can see that we have fully cosmetic threads going in there, all based off of that. Now, like I said before, this is 100% just for visual only. For your Solid Verify, this is not going to affect the G code, but if you guys do want to see those threads in there, definitely doing the shape tool to create those cosmetic threads is the way to go. All right, so now that we have all our thread milling done here, let's go ahead and play everything through. And we'll go ahead and run this through in Machine Sim. All right, let's zoom in here. So you can see our machine. Oop, I gotta go slow here. Doing our thread milling. This is the one that we had a bunch of passes on, so it's doing a couple passes there for us. I must have switched those around. Doing our NPT. And next we should be going to the 3/16 with the boss. And then cutting our physical threads right there, making sure we're not crashing into anything within our fixturing or tooling like that. So that is a completely finished part here. if I want, I can go ahead and turn off the machine. See a little bit better. Any questions with thread milling?
I've got one.
Oh boy.
Ronnie set the bar here, so I have to do my best to try to one-up him. But within thread milling, we've seen a couple different strategies here, and you've shown a strategy that has taken the thread in multiple Z depths, and then you've also shown strategies that are a continuous helix. Is part of a stump the instructor question. What's the differentiating factor between whether or not we're going to take this in multiple Z depths or as one continuous helix?
All based off of the number of teeth. So what I mean by that is, if I pull up our Harvey tool here, if we have multiple teeth, we can, if we have teeth up to here, we can take this all in one cut. Where if we only have 2 teeth and maybe those teeth are only 50 thou tall and our hole is 500 thou deep, it's going to have to take it in multiple passes doing a helical entry going in. Versus if we have multiple teeth thread mill, let me just go back to thread milling cutters here. If we are looking at a cutter.
Yeah, maybe you can show a representation on one of the external thread bosses and just show the difference with multiple teeth.
Okay, so what I'm getting at with the multiple teeth is, see right here. So if we look at this exact picture right here, all SolidCAM is concerned about is how many of these teeth that we have. So on this particular one here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 teeth on this cutter that's just kind of being shown right here. So if we are running 11 teeth on there, we'll go ahead and let me turn off our toolpath here so I can see what I'm doing. For our 3/8/16, so you can see we're doing multiple, it's spiraling down because it only has 1 tooth. Come on. So we go to tool, select. And what did I say, 11?
Yep.
So now you can see that our cutting length has automatically updated based off how many teeth we're cutting. So now, if we go ahead and accept that, save and calculate, now you can see it's only taking it all in one pass. And the reason why, if I can get this orientated correctly for you guys, is because here's our cutter, has all those teeth on there, and our threads are only 1/2 inch tall, but our cutting length is actually 687 thou. So it can do it all in one pass, going about that way. Now, if you want to take it in slow increments, working its way down, that's where in our technology, we can do, we can step it out, working its way into the material using our clear offset, or what we can do is if we wanted to step down more like what we're doing at the single point, is we can just reduce the number of teeth on there and just kind of lie to the software. Is that kind of what you were looking for, Greg?
Yeah, exactly. So I just wanted everybody to be aware that we are going to be utilizing the cutting length of that particular thread mill. That way, if you do have longer threads and you don't want to have to circle and interpolate the entirety of that helix, because you basically are wasting that flute length, we can do it in multiple steps based off of that cutting length. So like if Kevin were to adjust the number of teeth to, let's say, 4 teeth, we might see multiple passes here.
So now
instead of that 11.
Yep. So if we go down to 4 teeth, that brings our cutting length down to 1/4 inch. And now if we do save and calculate, it's going to do it in 2 passes versus 1 pass. because we have a total length that we're cutting as 499. So, yep, great point.
So, and I also chose 4 teeth very specifically because anytime you have 3 teeth or less, it's going to do the entire helix. So if you do want it to cut everything, even if your tool has more teeth than what you specify, if you set that to 3 teeth or less, you will get the entire helical profile. As soon as you go above 4, then we start breaking it up and optimizing that tool path.
So, great point.
And
I would have never even thought of that. What'd you say?
I sweated a little bit, but not much.
Well, I figure you got to put you on the spot a little bit, like you do with me. No, but great point there, Greg. Thank you. All right. Any other questions, guys? Did we figure out what the NPTF stands for? Is it the for fuel?
According to the website that I provided, it did specify that it was a designation for fuel-based threads.
See, Greg knows it all. He knew that off the top of his head.
Well, that, and I also cherry-picked the article, so
Oh.
for those out there at home, definitely look into it yourselves. But yeah, the first one I came across was for fuel-based threads. Basically, they're just adjusting the crests of the threads from a normal taper pipe thread.
Gotcha. Well, cool. All right. Anybody else got any questions? Ronnie's been the only one piping up, but hopefully that kind of answers all your guys' questions. Excuse me, answers all you guys' questions, and hopefully you got something out of it. Now, next week, both myself and I'll get back to our website, Greg Payton will be gone at SolidWorks World, so we will not be having a class next week. Now, I highly suggest if you guys are in the Nashville area, swing on over to the SolidWorks World and come see us. Both myself, Greg, and Sydney will all be there, as well as the owner and more tech people there. But definitely, if you guys are in the area, come check it out. So we won't have a class next week, but the week after that, we'll get the ball rolling again, and we will be covering slot milling for everyone. So, all right, guys. Well, just want to thank you for joining the night class tonight. And like I said, hopefully you got something out of it. And any questions come up along the way, just let me know. Everyone has my email address. If you guys don't, it is in the GoToWebinar, as well as if you guys are watching this on YouTube, it is in the description of the video as well. So, all right, everyone. Thanks again, and we will see you guys in a couple weeks. Bye-bye now.